get ID, get UID, okay? It's the user ID, it's not process ID. Okay. Wait, PID, wait for process. 20. Yeah, get PID. So you can use such a system code. You don't have to memorize all of them, just as long as you have this kind of reference word, mostly you can use the Wikipedia or their system manual or the Google, you can find easily. Then you can do the system programming. Okay, so this is the purpose of the system course. Is it true? Write once, run anywhere? Yes, it's true, but mostly compile once, debug every time. So this is an example of the system code, how we can use this. So in your source program, sometimes you may not realize, you may not use this kind of the system code directly. Why? Which means you don't use the system code? No. It's actually, even this one is some of the user do not like to directly use the system code. It's complicated. So is there any way, the easy way or simple way? So they provide, program language provide the API, their own API that they use this system code inside. So for example, to create a process, you need to call to the system code, fork and exe, but I'm lazy to use both of them. Sometimes confused. So Windows programming provides create process function. So simple. Java provide runtime the class. So runtime, so you can actually create another process on another Java virtual machine, something like that. So inside that such an API, they actually use a system code. Okay. So for example, if you this is a sequence of the system code to copy the file. Okay? When you copy the file, so you can just comment or just a function you can use provided by your programming API. But in your programming API, they actually use such a system code to copy the file. So this is the example of the C code to copy the file. You can use the open, that is the API, and the file status, and the open, send the file, and close. So this is a system code. Instead of using this one, you would like to use the API provided by your program. This is a Windows API. Windows. I know. This is another programming API for Wii. So to simplify, instead of using directly the system code, we can actually read the file or write the file. However, this function is based on the system code. So system programming required to understand and the ability to use such a system code. That is different between system programming and application programming. I don't think we have a Unix programming class, but several years ago we had. So if you take the Unix programming class, you will learn such a system program. So this is the programming, C++, I think the programming to create a file. You cannot see system code. However, inside the create a file, the API they use the system code. So we learned about the two modes, the user mode and kernel mode. So user is the application level. When application level execute the command, then the main job will be taken by your kernel, which is called the kernel mode. Actually, system code, system function will be executed by your kernel. So only application program request that the system, your operating system will execute the real system function. One of the reasons It's a security purpose. If we operating system allow end user to access the hardware, sometimes conflict, okay? Sometimes not protected, especially the memory, because memory is a lot of in and out replacement. So operating system take care to execute the system code. That is the reason we have the user mode and kernel mode. Then user will receive only the output, okay, the return code. So it is based on the parameter passing. We just send not the real execution. Instead, we can provide or receive the parameter value. So there are different ways. Pushing is a keep, send the parameter value, or it can be stat area. Then also the program will pop out from the parameter passing to communicate the user mode and kernel. There are different types of the system code. So these, the 190 or the sometimes 200 something system code can be classified by the several groups. One is the process control that can create process or terminate the process and end over and so on. You don't have to memorize this, just realize there are a group of the system code for process control. So probably in your the warming up assignment, you will use, sometimes you can directly, if you are using the low level is still high level languages like the C or C++, you can directly use such a system code, it doesn't matter. Or you can use the program API to create the process and communicate. And another group of the system code is a file management, like the create file, delete file, but they are simplified by the programming API. So you don't have to worry about too much for the system code, but you better know whether such a system calls are used in your API or not. For the communication, so we can create the communication method, then like using, for example, I try to create the queue or message queue or the something semaphore, or we can create the socket program, the method, then send the message, receive the message. So for example, it's client to server. So warming up program, the project will utilize one of the methods in communication and be able to create the process. Okay. These are the incomplete list of such a system code both from the Unix and the Windows. You can see something the comparison, but Windows also provides such a API, the system code. This slide shows how when you use the printf. Printf is the display, okay, your data. Okay, at the time, how the system code is executed in terms of the system code. It use the right system code, okay. From this is a user mode application program. This is a kernel mode. The kernel will execute actually system code that is the right, okay. But printf is the API command, API function in this the C language, not system code system function. But mostly you are familiar with this one because this is a little bit low level programming. I'm not going to explain details, but this part you understand. The system programs mostly utilized are based on such a system calls instead of the API. So from time to time, I have been asked by the student, I want to get a job that focuses on something system programming or administrative job. At that time, what can I do? My answer is you'd better get familiar with such a low-level approach. Like in terms of programming, it will be the system core and some data structure part, and mostly the core subject that you learn in this the major. Okay. That is the system programming. Then, so we have the different types of the system program. Application program, you probably know that you have been familiar with such an application program. But most of the system program is running on as a background, okay, as a part of the operating system. The background service we will see a little bit more later, so like the daemon program, okay, or sometimes it's called with Windows it's called the service. So we will see the more details about such background services. Okay. Now, after we learned what is the computer architecture and what is operating system, how the operating system service are organized, then it's time to develop the operating system. Okay. So we are not going to develop the new operating system. Instead, we will understand the operating system itself. However, if we still, there are many jobs that require such a design and implementing the operating system. Don't imagine the operating system usually like the Windows or the Linux system, but embedded operating system dedicated to the small device. It can be operating system also. Okay. Also, if you are from the computer engineering or electrical engineering, each device has an embedded system, embedded operating system. That's also operating system. Okay. So at the time we need to design such a operating system. It's basically you need to consider the two part, user and system. That's true because the operating system is in between user and computer hardware, right? So if you consider only the user, which means very convenient, it's a very fancy, nice the interface, and a lot of graphical user interface that my daughter likes. Most of the time, when my daughter gets the new device, she actually decorates a lot, like all the functionality. Then she complains, it's slow. That's true. So you need to also consider the system work. In terms of system, it should be simple and manageable and performance, something like that, and security. Okay. However, still you need to consider the user, the perspective, like how much convenient to use such an operating system. Also, whether the system is reliable or safe. So you need to consider two perspectives, the user and the system code. This is one of the ways, but even I do not have the real experience to develop the operating system, but it's first we need to design the policy. I think this is from the software engineering, so not only for the operating system, but it's a software engineering perspective. But we design the policy, what kind of the operating system we are going to pursue. Okay, then think about the algorithm, how. Okay, not from the approach first, but what is the goal, and then decide the goal. Then when we implement the operating system, still many of the parts, so C or C++ still. Okay? Android is the same thing, even though it's a Java interface. So most of the operating system are mostly the still assembly language are used, but it's less than a half most of the system. Only core part is directly implemented by the assembly. The other, usually C or C++, roughly 20 to 80%. 20% is assembly, and the others are high-level languages like the C. High-level language does not mean that directly the very high-level language like Java is also considered as the operating system, but mostly C or C++. Okay? But nowadays, if you are taking the Android, So you don't have to use the Android device. You can use emulator. Okay. Similarly, when you develop the operating system, actually without the purchasing the real hardware device, actually you can develop the program, operating system or the application program using emulator. It's the simulate your hardware. Okay. So there are many different types of operating systems. The Bill Gates starts from the Microsoft DOS. I'm not sure whether Bill Gates developed entirely MS-DOS. I don't think so. Actually, it's modified existing the DOS program. Then they made the first operating system, the MS-DOS. Okay. More complex, the Unix, and nowadays many of the Linux-based operating system and layered approach. That is the reason there are different versions of them. I don't have to mention about a lot the MS-DOS. Actually, MS-DOS is something. It's an operating system, but it's a single. It supports only single job, single process. Okay, at certain time it can execute only one process. That's a limitation. That is the reason. It sometimes other application program allowed to access the hardware part. That caused a lot of problems. So Microsoft gave up to use the MS-DOS from the Windows XP. The Unix system. This is from the also 1969. So 1969 is very important. Can you help me? Do you know what is this? This is a family tree of Unix. This is from the 1969. Okay. So what is the end of the year?
2000.
Let's say 2006. So it's 8 years ago. So pretty much it will be much longer than this, right? So the reason why I show you is the Linux and the Unix system has been developed a lot, so you don't have to just leave it. If you have any interest to learn about the history, you can download the PDF file. It's keep updating. So I suggest hire to update my printout. I usually use it once a year in the class to show how much big the parameter Unix parameter is. But mostly there are two branch from the 7th. Also, when you turn on the system, the Unix or any system, actually the clock time starts from 1970.
Yeah.
Because that is the first time to release the commercial version. But mostly it can be classified into the SPR or the BSD Berkeley, the Unix system. Most of Linux system can be classified into two. Each group has sometimes comparable, sometimes not, but it's mostly classified into two groups SPR version. That includes the SunOS mostly and HD or the BSD. The old SunOS or some other. Okay. So I'm going to stop here because today we have the invited speaker in Engineering 400. If you are taking the Engineering 400, why don't you be in a hurry? Otherwise, it's welcome to join today's presentation. It's an internal speaker from the physics department, whose name is Dave Kraft. He will present about something interesting in the physics. Okay, thank you so much. We will see you on